The next topic we're going to look at is multiple diode circuits. So of course, in general, we can say that diodes can either be on or off. Realistically, there's some gray area in between, but for our purposes, we're going to assume it's pretty clear cut that they're turned on and they're well into the forward bias region, or they're well into the reverse bias region. So as we've talked about before, if a diode is on, we can approximate it using our piecewise linear model with a voltage source and a resistor in series. So we can approximate with a source voltage equal to the cut-in voltage V gamma and some resistance R sub F in series. And for most cases, we're going to assume that RF is 0 unless told otherwise. Now, when our diode is off, what we can do is we can just approximate it as an open circuit. We say that it's not allowing any current to flow. So approximate as open circuit. And again, we know that there's going to be some small amount of reverse bias current flowing, but we're saying it's small enough that it's basically negligible. So we know we have these two possible states for our diodes. So what that means is, let's say we have two diodes in a circuit. So with two diodes in a circuit, each diode has two possible states. So overall, we have four possible states for the circuit. And so if we called the diodes D1 and D2, our possible states would look like this. We could have D1 off with D2 off. We could have D1 off with D2 on. Or we could have D1 on, D2 off. Or finally, we could have both diodes on. One important thing to mention as we're looking at these potential states is all of the states might not be physically realizable. So all states might not be feasible. And that's just dependent on the circuit configuration. So all states, we'd say might not be feasible. So maybe our circuit configuration is such that the two diodes can't be on. We have some conflict where that would cause the characteristics to not both be on. So we couldn't have the same forward voltage or something with the configuration. So it's difficult to explain without looking at a particular circuit. So of course, this is just for two diodes. We can see how quickly that would scale up. So for instance, if we have three diodes, we then have 8 possible states. And so what we can see is this is essentially for two states, we have 2 to the power of 2. For three states, we have 2 to the power of 3. For four states, four diodes, we'd have 2 to the power of 4. So it keeps on getting higher and higher. And so the point I want to make there is that as we get a large amount of diodes, really even more than 3 diodes, what we want to do is start using a computer simulation instead of trying to figure out all of this by hand. However, if we just have two diodes or even 3 diodes, or in some cases, depending on the configuration, we can do it with more, hand analysis is feasible. So the question then becomes, how do we do that hand analysis if we don't have a complex system? Well, the basic process is we're going to make assumptions about the diode state. So make assumptions about diode states. And so what that means is basically we're going to assume diode 1 is on, diode 2 is off, for instance. Our next step is then to analyze the circuit like we would normally. And so of course, when we analyze the circuit, we come back up here and we're using these approximations. So if we assumed it's on, we're approximating it as a voltage source with that resistor in series. If we assumed it's off, we're approximating it as an open circuit. So once we analyze the circuit, what we need to do then is we need to come back and check our assumptions. So how do we check our assumptions? Well, there's more details in a document posted on Canvas, but just briefly, if we assumed that our diode was on, for instance, and we end up finding that our diode current is negative, then that means something is wrong with our assumption. Similarly, if we analyze our circuit and we find that for a diode we assume to be off, we have a diode voltage greater than our cut-in voltage V gamma, then we have an incorrect assumption somewhere. So after we've checked our assumptions, if everything looks good, that's our answer. If we have anything that's wrong, then we need to change our assumptions and redo our process. So change or revise the assumptions, and then come back up here and analyze and check assumptions again. And so again, for this check assumptions, and actually really for this whole process, let me just say that there are details posted on Canvas. So there's a PDF handout that you can look at, and that's adapted from page 101 in the textbook. And so what we're going to do in the next couple of videos is look at an example of how we analyze a circuit with two diodes, and we'll see how that looks when we make correct assumptions and how it looks when we make incorrect assumptions.